Hello students, so we were seeing the inverse of a matrix by elementary operations, right? So we'll solve one question. Okay, there is one matrix given here. You have to find the inverse. So you can use any of the method, that is by row operations or column operations. We'll solve this question in both the ways, that is row and column. Okay, so let's start with our row operations. So for row operations, I've told you to use A is equal to IA. Yes. So let's write your identity matrix 1 0 0 1 into A. Now you have to start. This is a row operations. So you have to start from 1, then 0, then 1 and 0. So this way you have to go. Now here first element is already 1. Now we have to make this 0. Okay. So if we are making this 0, then we are working on row 2, right? This is row 1, this is row 2. So we are working in row 2. So start with row 2. So we are changing our row 2. Okay. So row 2, if you want to make this 0 using row 1, then R2 minus, we have to multiply with 2 here, right, to R1. Okay, so start with this. Row 1 will be same. Okay, keep as it is. Now R2 minus 2 R1. So this is 0. Now R2 minus 2 R1. So minus 2 into R1 is 2, right? So this will be minus 1 minus 4. So this will be minus 5. Now same operations you have to carry here also. Okay. So our row 1 remains same. Row 2 you have to change. So R2 minus 2 R1. So this will be minus 2. R2 minus 2 R1. R1, R2 remains same. Okay. Now we have made this 0. Now you have to make this 1. So to make this 1, you have to divide by minus 5, right? So we are changing again R2. So R2 you have to divide by minus 5. So R1 remains same. This will be 0 and this will be 1. Here R1 remains same. R2 we are dividing by minus 5. So this becomes plus. Okay. Now we have to make this 0. So to make this 0, you have to make use of R2, right? So R1 is 2 minus 2R2, right? So we are changing R1. So R1 minus 2R2. So this is not changing. Our R2 is same. This will be 0. R2 remains same. Now here R1 is 1. 1 minus 2 into R2 is 2 by 5, which is 4 by 5. So 5 minus 4, it will be 1 by 5. Okay. For R1 0, 0 minus 2 into minus 1 by 5. So this becomes plus 2 by 5. Okay. So this is your A inverse. Okay, whatever we get here, this becomes your A inverse. That is, we are proving this as I is equal to A inverse A. Okay, so our A inverse is 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. This is our A inverse. Okay, let's prove same thing by using column operation. Okay, so let's start. For column operation, you have to use A is equal to A into I. Okay, so write your A matrix 1, 2, 2 minus 1 equal to A into I is 1, 0, 0, 1. Okay, so let's start with column operation. So for column operation, okay, you have to start from here, then here, and here. Okay, so here 1 is already there. You have to make this 0. Okay, so for row we have taken R2 minus 2 R1, like that. Here you have to take column, that is C2 minus 2 C1, like that. So we are changing C2, right? This is your C1, this is your C2. So we are changing C2. So C2 minus 2 C1. So this will be 1, C1 remains same. C2 minus 2 C1 is 0. C2 minus 2 C1. So minus 1, minus 2 into minus 1. Minus 1 minus 2 into 2. So this will be 5, minus 5. So C1 remains same. For C2 minus 2 C1 here. C2 minus 2 C1. So this is minus 2. Then C2 minus 2 C1, 1. Okay. Now we have to make this one. So to make this one, you have to divide by minus 5. Okay. So we are changing again C2. So C2 divide by minus 5. So 1, 2, 0, 1. C1 remains same. So this will be 2 by 5 minus 1 by 5. Okay. Now you have to make this 0. So to make this 0, you have to make use of C2. So we are changing C1. So C1 minus 2C2. So C1 we are changing. This remains same. This will be 0. Two by 5 minus 1 by 5. C1 1 minus 2 into 2 by 5. So this will be 4 by 5. So it is 1 by 5. Okay. Then C1 is 0. 0 minus 2 into minus 1 by 5. So it is 2 by 5. Okay. So this is of the form I equal to A into A inverse. So your A inverse is 1 by 5, 2 by 5, 2 by 5 and minus 1 by 5. Okay. Let's solve one example from exercise. Okay, so this is exercise 3.4, example 16. Okay, this is a 3 by 3 matrix. So we'll start with the row operation. Okay, so A equal to I into A. Okay, so write your matrix 1 minus 3 2 3 0 5 minus 2 minus 5 0 1 0 0 0 1 0 0 0 1 to A. Okay, so already here 1 is there, so we have to make this 0 and this 0. Okay, so we have to work with R2 and R3. So to make R2 1, we have to make R2 plus 3R1, right? And R3 we are changing to R3 minus 2R1. Okay, so we'll get 1 0 0 0 plus 3R1, so 9, minus 5 plus 3 into 2 minus 6, so this becomes 11. Then 5 minus 2, so minus 6, so this is minus 1. And 0 minus 2 into minus 2, minus 4, plus 4. Okay, same operations we have to carry out here also. So R1 remains same, R2 plus 3R1, so 3 R2 1 2 1 0, then 0 minus 2R1 minus 2 0 1. Okay, now we have to make 8R1 1 0 0, then we have to go for 0 1 0, so we can make this as 1, right? So start with, now we have here minus 1, so we can make use of this minus 1. Okay, so if I multiply this by 3 and add it to R1, then this will be 0. Then if I multiply this by 8 and add it to R2, then this will be 1, right? So you can take operations on R1. So R1 plus 3R3 and R2 plus 8R3. Okay, so you'll get here 0 1 minus 1, so R3 remains same. This will be R1 plus 12, so this is 10, and R2 plus 32, right? Now you have to carry out those operations here also. So R1 plus 3R3, R1 is 1 plus 3R3, 3 to the 6, minus 6, so this is minus 5. Then R1, this will be 0, R1 plus 3 3, so R2 plus 8R3, R2 plus 8R3, 16, right? So this will be 13. Then R2 plus 8R3, so 1, R2 plus 8R3, so 8, 2A. Okay, now this is 1 0 0 0 1 0. Now make this as 0, so you can add this 2. So we are changing R3, so R3 plus R2, right? R3 is 4 plus R2, so 25. R3 plus R2, so 11 minus 2 minus 11, 9. And we are adding this, so it will be minus 15. Okay, now this is 1 0 0 0 1 0. Now you have to make this as 1. Okay, so divide R3 by 25. So 1 0 0 0 1 0 10 21 1 minus 5 0 3 8 minus 15 by 25, 1 by 25, 9 by 25. Okay, now you have to make these two zeros, so you have to carry out operation on R1 minus 10 R3 and R2 minus 21 R3. Okay, 1. Now your R3 remains same. R1 minus 10 R3. R1 is minus 5 minus 10 into minus 15 upon 25. So this will be 6 minus 5 plus 6, so it is 1. Then 0 minus 10 R3, so it is minus 10 by 25. Then 3 minus 10 into 9 by 25, so 90 by 25. So 75 minus 90 by 25. Oh, this is 1 by 25, so this is 0. Okay, so this will be 15 by 25, right? Minus 15 by 25. Okay, next is R2 minus 13 minus 10 R3, so plus 10 into 15 by 25, so this comes to be 6, right? Ah, 21 it is, not 10, so this is 21 minus minus plus. Okay, so this 5 remains, so you have to multiply this. Minus 13 into 5 minus 65 plus 63 upon 5, so this is minus 2 by 5. Okay, next is 1 minus 21 upon 25, so this is 4 by 5. Then 8 minus 21 into 9 upon 25. Okay, 200 minus 189, 125. So this is 11 by 25. Okay, so 1 minus 10 by 25 we can write. So your A inverse is 1 minus 2 by 5 minus 3 by 5. It's 2 by 5, 4 by 5, 11 by 25 minus 3 by 5, 1 by 25, 9 by 25. This is your A inverse. Okay.